Hello guys, I am Ranjan Mishra from Revolution Physics Ghaziabad and we are going to derive the refraction formula today. Okay, the formula that is a foundation for deriving lens maker formula and lens formula. So it is very important formula. Okay, let's derive refraction formula. Let's have a convex surface. Remember that we are deriving here for a convex surface, but the formula will be valid for concave and convex both. Here we are going to derive for convex surface. Okay, this is a denser medium having refractive index mu2 and this is a rarer medium having refractive index mu1. Let's object be at point O and light fall on the surface. If there is no medium change, then light might have passed from this path, but as medium is changing, it will bend towards normal. Okay, this is the normal, so light will bend. Light will bend towards the normal and final image is formed at I. Okay, this is O and let's consider it as a P and draw a perpendicular from point A on the axis. Now this is offset, so this will be the object distance U and this is center of curvature, so it will be R and this is image, so it will be V. This is the simple diagram. Now the main equation we are going to use is a Snell's law. What is a Snell's law? Mu1 sine I must be equal to mu2 sine R. But for small angles, we can neglect sine, and this is also for tan theta we will use in this equation. So you can write mu1 I must be equal to mu2 R. Now let us have I. What is I? Incident ray make angle I with the normal, so it will be I, and refracted ray make angle R with the normal. Okay, now we know that, let us say it alpha, this angle at beta and this angle at theta. Now we know that exterior angle must be equal to sum of interior angles. This is exterior angle and alpha and beta is interior angles in triangle AOC. In triangle AOC we can write angle I must be equal to angle alpha plus angle beta, angle alpha plus angle beta. And what is angle alpha? This is alpha in triangle OAM. In OAM, in this triangle OAM, tan alpha will be AM upon OM. It will be AM upon OM. Okay, plus beta in triangle ACM, tan beta will be AM upon MC, AM upon MC. Okay, now in triangle AIC, AIC, beta is exterior angle and alpha, R and theta is the interior angles. So you can write angle beta will be equal to angle R plus angle theta. Now we can write angle R as angle beta minus angle theta, and beta is integral ACM, AM upon MC. Beta is AM upon MC minus theta, integral AIM. Tan theta will be AM upon MI, AM upon MI. Okay. Now let's have a assumption, because this length is very small, because we consider the spherical surface very thin, we can consider OP as OM, and that is equal to minus U. MC can be considered as PC, and that is nothing but R. And MI can be considered as PI, and it will be V. Now put the values. mu1I, that is mu1, and what is I? I is AM upon OM, AM upon OM plus AM upon MC, AM upon MC equal to mu2 R. What is R here? AM upon MC, AM upon MC, it is AM upon MC minus AM upon MI, AM upon MI. Now see, AM is common, AM, it will be cancelled out and rearrange it. It will be mu1 upon OM plus mu1 upon MC equal to mu2 upon MC minus mu2 upon MI. Now take mu1 upon MC in other side and mu2 upon MI in left side. It will be mu1 upon OM plus mu2 upon MI, that will be equal to mu2, and this is minus mu1 upon MC. Now let's see, OM is equal to minus U, and MI is equal to V. So put the values, mu2 upon V, because this is positive and OM is negative, so I am putting minus mu1 upon U, and that is equal to mu2 minus mu1 upon MC. MC is R. Okay, this is the final result, and this is called refraction formula. Here we have derived the formula for convex surface, but this is valid for both concave and convex surface, and this formula is very important for deriving lens formula and lens maker formula. Okay.